So we're going to review the concepts from Module 8 before the test. So the beginning of the module, we talked about finding mean, median, mode, standard deviation for a set of data. So we have the data set 13, 6, 4, 2, 2, 3, and 16. And the first thing we want to do is find the median. So remember, in order to calculate median, your values have to be in order. So 2, 2, 3, 4, 6, 13, 16. And then you start crossing them off starting at the end. And we end up with 4 as our median. So if you have an odd number in your data set, you will be left over with one number. If there were an even number of data points, we would have been left with 2 numbers, and then you just add those 2 numbers together and divide by 2 because you have to find the middle of those 2 numbers. The next thing we want to do is find the mean. So in order to find the mean, you add all the numbers together. So 13 plus 6 plus 4 plus 2 plus 2 plus 3 plus 16, and then you divide by the total number of pieces of data, which in this case is 7. And when you add all of those numbers together and divide by 7, you get a mean of 6.57. Next, we want to find the standard deviation, and you are going to be able to use Desmos to calculate the standard deviation on the test. So remember, when you go to Desmos, you type STDEV, and then you list your numbers, and they don't have to be in order, and you just separate them with commas, and you should get 5.65. So remember, standard deviation tells us on average how far each number is from the mean. It's the spread in the data. So a larger standard deviation means there's more spread in the data. A smaller standard deviation means most of your values are close to each other. So a larger standard deviation here is to be expected since we have those 2 numbers 13 and 16, which are really far away from most of our data points, and they actually pull the mean to be a higher number than if we had just had 2, 2, 3, 4, and 6. So that leads us to number 4. If we add an outlier to the data set, say 75, what statistical value changes the most? Show your work. So we're really just going to talk through which one changes the most. So mean and standard deviation are affected most for outliers. So mean, because you're adding all of the numbers together, and if you have a value like 75, that's a lot bigger than all of the other data, it's going to make your mean a lot larger. Same thing with standard deviation. Because standard deviation is like a distance from each value from the mean, because a larger value pulls that mean to a bigger number, it's also going to tell you have more spread in your data. Median, because that outlier is such a large number, it's going to get crossed off first. So it's not going to necessarily have as big as an impact on the median. Same thing with mode. Since mode means the number that appears the most, it's not going to be affected by an outlier because the number that appears the most is still going to be 2. So the next thing we discussed was correlation. And this is another thing that we're going to use Desmos to calculate. So what you do is you're going to add the table of x and y values to Desmos, and then you're going to type the equation y1 with the tilde mx1 plus b. And the correlation is that r value. So after you type that into Desmos, it's going to put a line through your data points, and when we look at R, we see that it is negative 0.8928. And based on that that R value, we want to describe the correlation. So that means, is it strong or weak, and then is it positive or negative? So R value is obviously negative because it's a negative number, and then the strength is how close is that R value either to positive 1 or negative 1, depending on if it's positive or negative. And 0.8928 is pretty close to -1 when you add in that negative. So it's also going to be a strong correlation. We are also going to do the same thing for our next example. So our next example talks about the relationship between unit price and unit sold. So the unit price is going to be our X values. And then our Y values are going to be our units sold. And in order to see this graphed in Desmos, you are going to have to zoom out a bit to see all the points because our Y values are so large. But you're still going to type that same equation that we used on the previous problem, the Y1 mx1 plus b, and we're going to still look for R. So in this case, R is going to be -0.1477. So if we're describing what this means in the context of the data, so we know that it's negative, because again, R is negative, but this time 0.1477 is actually pretty close to 0. So there's a negative and weak relationship between unit price and units sold. So it basically means the more expensive the unit is, the less units are sold. But there's not a very strong relationship between the two. So for the next few problems, we're going to use our spinner to find some probabilities. So the first thing I do is figure out how many spaces are on the spinner. So there are 12 spaces. So that's going to help us for our probabilities. So the first probability we want to find is the probability of spinning a 2. So we have to figure out how many 2s are on our spinner. So there are 2 2s, which means the probability of spinning a 2 is going to be 2 out of 12, which does simplify to 1/6. Okay. Next, we want to find the probability of spinning a 3. So there are 3 3s. So we get 3 out of 12, which is 1/4. Next, we'll look at spinning a 4. So there are 2 4s. So it's going to have the same probability as spinning a 2, which is 2 out of 12, which is 1/6. And then lastly, spinning a number less than 5. So there's going to be some overlap here with our other ones, which is fine. So 1, 4, 3, 2, 4, 3, 3. So 8, it looks like. So 8 out of 12, which is the same thing as 2/3. Another way you could have thought of that last one, probability of spinning a number less than 5, we can just do 1 minus the probability of spinning a 5. Since 5 was the biggest number on our spinner, it's basically saying anything but 5 for that last one. So those were single probabilities, which is what we did in section 4. We then, in section 5, talked about probability of A and B and probability of A or B for independent events. So the probability of A and B is when we multiply. So probability of A times the probability of B. Remember, as long as they're independent, the probability of B, you don't have to worry about changing the denominator or maybe even the numerator. Probability of A or B was when we added. So probability of A plus the probability of B minus the probability of A and B. So remember with or, we have to subtract that overlap. The probability that if you're doing multiple things, that if you we'll take a look, but if you're drawing a card and you're like, what's the probability the first card is a heart? Or, on the second draw, I get a spade. You have to subtract the probability that when you draw your two cards, you get a heart and then you get a spade. So let's start with an example where we are rolling a die. So we want to find the probability of rolling an odd number or rolling a 3 or higher. So we're going to let rolling odd be A and a 3 or higher be B. So probability of rolling an odd number is 3 out of 6 because 1, 3, and 5 are the odd numbers. Then we want to add the probability of rolling a 3 or higher. So that's 3, 4, 5, and 6. So there are 4 outcomes there. Now, if I had just stopped here and I didn't subtract the probability of A and B, I would get 7 over 6, which is not possible because probabilities have to always be between 0 and 1. So now I have to subtract the probability that when I roll a die, I get an odd number and a number that's 3 or higher. So the odd numbers that are a 3 or higher are 3 and 5. So 2 out of the 6 outcomes. So 3 plus 4 is 7, minus 2 is 5. So there's a 5 out of 6 chance that we roll an odd number or a 3 or higher, which makes sense because the only number that isn't odd or a 3 or higher is 2. So it makes sense that we have a pretty high chance of getting that. Next, we want to find the probability of rolling double 5s. So that's the same thing as saying the probability of 5 and 5. So this is an and probability. So the probability of the first outcome being a 5 is 1 out of 6 because 1 out of the 6 sides is a 5. The probability of the second roll being a 5 is also 1 out of 6 because these are independent events. Each time I roll a die, it forgets what happens before. And when you multiply straight across, you get 1 out of 36. Okay? And then we want to find the probability of rolling 6, 6, 6 in 3 rolls. So it starts off the same way as rolling double 5s. So probability of rolling a 6 is 1 out of 6. Then getting it again, 1 out of 6. And if a third time, still 1 out of 6. So it ends up being 1 over 216. So it's always a pretty small chance that you roll 3 of the same number in a row on a die, but it can happen. The last example we're going to look at is we have 2 events. Event A is drawing a random number between 1 and 10, and event B is drawing a random number between 51 and 100. And we want to find the probability of picking a 7 and picking a number greater than 88. So this is our and probability. So we're going to be multiplying. So event A is going to be picking a 7, and event B comes from greater than 88. So there's in the numbers 1 through 10, there's only 1 7. So 1 out of 10 times. So numbers greater than 88, there are 12 of them, and then 51 to 100 is a sample size of 50. So when we multiply straight across, we get 12 over 500, which we do want to simplify, which is 3 out of 125. So not a very big chance that you pick a 7 and a number greater than 88. So now we're going to take a look at OR. So probability of picking a single digit number, so that comes from event A, or picking 70, which is from event B. So in event A, there are 9 single digit numbers because it's the numbers 1 through 9. 10 is not single digit. So we have a 9 out of 10 chance of picking a single number, plus the probability of picking 70, which there's only one of those out of 50. Then we have to subtract the probability that when I draw from each sample, I get a single digit and I get 70. which remember is when we multiply, which is 9 over 500. Now I'm going to use the calculator to do this for me so I don't have to get common denominators, and you are more than welcome to do the same thing on the test. And we get 451 over 500. So there's a pretty good chance that when you draw a number from each event, you're either going to get a single digit number or a 70, which makes sense because event A, 9 out of the 10 numbers are single digit. So it's more likely that when you draw from each event, you get a single digit rather than you get the 70. So let me know if you have any questions before the Module 8 test.